homework 5 notes 1, which is on linear programming. Okay. So, for example 1, Otto Toyon builds toy cars and toy trucks. He needs to decide how many cars and trucks to manufacture so that he can maximize the amount of money he makes when he sells them. Some details of his toy business. Otto makes $4 on profit each car he sells and $8 on each truck. Each car needs 4 wheels, 2 seats, and 1 gas tank. Each truck requires 6 wheels, 1 seat, and 3 gas tanks. His warehouse only has the following parts available: 36 wheels, 14 seats, and 15 gas tanks. So first off, I'm just going to go ahead and separate these in color. Okay. And then we're going to go ahead and define our variables. So what is it that we're looking for? That is how you want to define your variables, is what it is that you're trying to find. We are trying to find the number of toy cars and the number of toy trucks. So that will be our X. And this will be our Y. I'm sorry if my handwriting is really ugly. This pen is being it's kind of messed up now. So, okay. So we have a constraint. So basically, that is what it is that we're specifically talking about. The only variable that we're talking about for this first one is wheels. Then we have seats, and then we have gas tanks. We're gonna end up making an inequality. The inequalities will be in standard form, slope intercept form, point slope form. It just honestly depends on what we have, and that's how it'll be. And then we're going to solve for the x-intercept and the y-intercept and solve for slope intercept form. So if you can add this onto your table right here, because slope intercept form really is the easiest to graph. Okay, so starting with the wheels. So in purple, we're talking about wheels here. So we need, how many wheels do we need for the car and how many wheels do we need for the truck? Well, we need 4 wheels for the car, so 4x, and we need 6 wheels, so for the truck, so 6y, 4x plus 6y, and we only have 36. So remember, we're doing an inequality, so it's going to be less than, greater than, less than or equal to, greater than or equal to. So if you only have 36, that means that you can 4x plus 6y is going to be less than or equal to 36. So you can use all 36, or you can use less than 36, but you can't do more than. So you can't do it with this side here. You cannot do this side because you're saying that the amount of wheels is going to be greater than or equal to 36. So make sure this is less than or equal to 36. Okay, so looking at this, again, let's forget the equal sign is there in our x-intercept. So remember, our x-intercept, we cover up the y and we say, okay, 4 times x plus 36. Well, what does x equal? Well, 4 times 9 is 36. So 9 comma 0. And this was 6y. And then let's do the same thing for the x. So 6y is equal to 36. So 6 times what gives us 36? Well, that's going to be 6. So our y-intercept is going to be 0, 6. Okay. And off to the side, we're going to solve it for slope-intercept form. Okay, so I'm going to just off to the side, I'm going to rewrite 4x plus 6y is less than or equal to 36. So slope-intercept form, y equals mx plus b. First thing, let's go ahead and subtract the 4x over to the other side. So 6y is less than or equal to 36 minus 4x. I'm going to divide everything by 6 and simplify. So y is less than or equal to 6 minus 4 over 6, which is 2/3 x. So I have here y is less than or equal to 6 minus 2/3 x. Okay. For seats, so seats I have in green. So we need 2 seats for the car, so 2x. And we need 1 seat for the truck plus 1y. And what's our total? We have a total of 14. So again, this is going to be less than or equal to, because you can use all 14 or you can just use less than 14. Okay, so x and y intercept. My x-intercept is going to be 7, 0. my y-intercept is going to be 0, 14. Okay, so let's go ahead and again, let's solve this for slope-intercept form. So we have 2x plus 1y is less than or equal to 14. I'll subtract the 2x over, and we have y is less than or equal to 14 minus 2x. You do not need to keep that 1 right there, right? So that 1 just kind of is invisible. So that one was pretty easy to solve. So I'll rewrite that over here. Y is less than or equal to 14 minus 2x. Okay, and then our last one for gas tanks. Okay, so we need one gas tank, so 1x plus 3 gas tanks, so for the truck, so 3y, and we have 15 total. So again, we can use all 15 or we can use less than 15. And my y-intercept, you should be knowing it's already 15, 0, and my x-intercept, my x-intercept is 15, 0. My y-intercept is going to be 0, 5. So let's go ahead and solve that off to the side again. So x plus 3y is less than or equal to 15. Subtract 3y to the other. Oh, not subtract. What am I doing? Sorry, guys. I feel like I'm making so many mistakes today. Subtract x. 3y is less than or equal to 15 minus x. Divide everything by 3. Y is less than or equal to 5 minus 1 over 3x. So we'll write that down over here. Okay, so we have all four, not all four, oh my god, look at me. All three inequalities written in slope-intercept form and in standard form. So now we're going to just go ahead and graph. So is 3, 5 in the feasible region? Remember, feasible, this just means the solution region. Let me put that in black. Solution region. Okay, explain why or why not in the context of this problem. So first we need to graph, we need to label our graph, and we're going to solve for the points. We're going to solve algebraically with that. Okay, so first off, my x and my y. We already know that y is the number of toy trucks. You need to make sure you guys are labeling your graphs for this packet. And my x, I'm going to just put an arrow. Number of toy cars. Okay, let's go ahead and graph the first one, the one in purple. So it was, and we're graphing the slope-intercept form. Okay, so over here, 6 minus 2/3 x. So my y-intercept is going to be 6, and I'm going down 2 to the right 3. Okay, and this should be a solid line. Okay, and now we need to talk about the shading. Am I shading above or am I shading below? Well, I have y is less than or equal to, so I'm going to shade below this line. So all this area here. Okay, next line in green. My y-intercept is 14 and I have a slope of -2, so I'm going to go down 2 to the right 1. Again, we're working with a solid line here. And we have y is less than or equal to, so we're going to shade below. I'm only going to shade the region where the purple and the green are going to be shaded so far, okay, so I don't have to keep reshading. So I'm actually going to try and erase, all right, so let me put that purple line back real quick. So I'm trying to keep this neat. If you have all of your lines shaded, please don't worry about me. I'm just trying to keep mine as neat as possible. But you want to make sure that the double shaded region is this area right here so far. Okay. And then our last line is going to be y-intercept of 5, and we have a slope of negative 1 over 3, so down 1 to the right 3. Again, this is going to be a solid line, and we are still shading below. So we're looking for the area, the feasible region, the solution region is where we see all colors shaded. That's why I tell you guys to use my God, what am I trying to say? Colored pencils. It's a lot easier. So this is our region right here. Okay. So is 3, 5 in the feasible region? Well, let's go ahead and mark 3, 5. That's the right 3 and up 5. That's right there. No, it is not. No. So 3, 5 is not, we're going to have to do some room. So if you guys have to write on the back, please don't be afraid to write on the back. You guys don't have a back spot. But 3, 5 is not in the region. Because autotoyum will not be able to make, and again, 3, 5, that means it's 3 toy cars and 5 toy trucks. He will not be able to make 3 toy cars and 5 toy trucks with the available parts. Okay, so what we're going to do is we are going to plug 3, 5 into our equations, and we're going to see if they come out true. And that's why you'll see. Okay, so I'm going to do it 3 times. So first into our purple equation, we had 4 times 3 plus 6 times 5 is less than or equal to 36. We're checking to see if that's true. So I'm going to put a question mark. Well, 4 times 3 is 12, plus 6 times 5, which is 30, less than or equal to 36. Is 12 plus 30, that's 42, less than or equal to 36? No, it's not. Okay, so first, we don't have enough wheels. Let's do the next equation. That was 2x, so 2 times 3 plus 1 times y, which is just going to be 5, less than or equal to 14. Well, 2 times 3 is 6, plus 5 is less than or equal to 14. Is 11 less than or equal to 14? Yes, it is. So we have enough to make the seats. But let's go ahead and do the last one. We have 1x, which is 1 times 3, which is 3, plus 3 times 5 is less than or equal to 15. Well, 3 plus 15, should be putting my little question marks. This is 18. Is 18 less than or equal to 15? No, it's not. So we do not have enough gas tanks or wheels to make 3 cars and 5 trucks. It has to be true for all 3 of these. All 3 of the constraints, it has to be true. Okay, so now this is what we do. Okay. We're going to go ahead and solve for the intersection points algebraically. So you can see right here. I want you guys to go ahead and do that on your own, but I'll help you kind of set up what you need to do. Okay. I'm going to just erase this really quick. So on the back of your paper, solve for the intersection points because you're going to need them. Okay. We can see right here. So you're going to, let's just use our slope-intercept ones. And for these, you can just use equal signs when you're solving. Okay, so the first one is y is equal to 6 minus 2/3 x. So you're going to have 6 minus 2/3 x is equal to, let's plug it into the green, 14 minus 2x. Okay, so that's 1. Your second one that you need to solve is you need to plug the first one again. 6 minus 2/3 x is equal to the last one. 5 minus 1/3 x. Get x and get y. Okay, and then the third one, you're going to plug the second one into the third one. So your green into your pink. 14 minus 2x is equal to 5 minus 1/3 x. And again, you should solve for x and for y. You're solving by elimination, or substitution, sorry. So make sure you solve for x first and then solve for y. Okay, so we want to know the coordinates of the vertices of the feasible region. So the vertices are the points. Think of back to geometry. We have this feasible region right here. I'm highlighting it in black. It's like the edges, the sides, whatever, the vertices, the angles that they're meeting at, the points that they meet at. Okay, so there is 5 of them. Okay, first one here down in the corner, that's going to be 0, 0. Going straight up, that's our y-intercept is 0, 5. This one here in the middle, that's going to be 3, 4. And then we have 6, 2. And the last one is going to be 7, 0. So all those points that I marked in black, those are the coordinates of the vertices of the feasible region. And again, if this is going by really fast for you, just know we're going to be doing so much practice in class. The notes is just for you to kind of get a preview and to kind of understand what I'm talking about. All right, so the objective function is to maximize profit. Remember that they get $4 profit for each car and $8 for each truck. So write out the profit function. So profit, that's what we're getting, okay, and this is going to be a p comma xy is equal to, we get $4 for the cars plus $8 for the trucks. So that's the profit function. So how do we calculate the profit using the vertex of the feasible region? Well, those vertices, these ones right here, we're going to plug them in to our profit function or objective function. So first one, easy, easy, easy. 0, comma 0. Let's plug in 0, 0. So it's going to be 4 times 0 plus 8 times 0. That's going to be equal to 0 because anything times 0 is 0. So your profit is $0. Okay, next point to plug in is 0, 5. So 4 times 0 plus 8 times 5. 4 times 0 is 0. 8 times 5 is 40. So 0 plus 40 is going to be 40. So our profit is $40. Okay. 7. No, our next point was 3, 4. Sorry. So 4 times 3 plus 8 times 4. 4 times 3 is 12. Plus 8 times 4 is 32. So we add those together and we get 44. So $44. So if we make 3 cars and 4 trucks, we are going to make $44 profit. Let's keep going. We have 2 more to go. 6, 2. 4 times 6 plus 8 times 2. 4 times 6 is 24 plus 8 times 2 is 16. 24 plus 16 is 40. So we have another profit of $40. And then the last point is 7, 0. So 4 times 7 plus 8 times 0. 4 times 7 is 28. Plus 0 is obviously going to be 28. So $28 profit. And remember, the whole point of this question is how many trucks should this company make? How many cars should they make to maximize profit? Well, looking at this, which one has the max amount of profit? Which one is the highest? Right here, 44. 44 is the highest. So the company should make 3 cars and 4 trucks to maximize profits of $44. Okay, so please just make sure the only thing that you need to do on your own is this section over here where you're solving for the intersection point algebraically, meaning you're just solving using substitution. I already set up the equations for you. You just need to solve for x and y for both of them. Okay, so I'll see you in class tomorrow. Again, sorry for the late video. Goodbye, beautiful people.